Hello, this is Maria from Math Mammoth, and this is Mathy, my mascot. And today we are studying scientific notation with large numbers. And I have a really mammoth number here. Look at how big it is, Mathy. Oh, what is it, he asks. No, it's not the weight of yourself. No, it's not the weight of a mammoth. It's the weight or the mass of our sun. This huge number. How many digits does it have? 31 digits. Who would not start reading that? I mean, you would just get confused if you started reading that number to somebody. So that is why we use scientific notation. We use powers of 10 to get rid of all of those zeros, so to speak. We don't really get rid of them, we just write them with a shortened notation using exponents. So instead of this long number, we will say 1.9891 times 10 to the 30th kilograms, the mass of the sun. Now let's practice and write these numbers that are given in scientific notation in normal decimal notation. 8 times 10 to the 5th. 10 to the 5th would be with 5 zeros. You remember that? So this, as an intermediate step, we get like that, 5 zeros, so it's actually 100,000. We get 800,000. Notice that this is 10 to the 5th, and here we have 6 digits. So that will always work, that the number that we write will have one more digit than the exponent here, when we're using scientific notation. 2 times 10 to the 13th. 10 to the 13th has 13 zeros, and then the 1. So this number will have 14 digits and 2 times, so 2 here at the front, and then 13 zeros. Oh man, I almost ran out of space, and then we could put commas there. But it really doesn't make it that much easier to read. Just a huge number. Scientific notation is much easier to handle. Alright, next one now, it has a decimal number here, 4.71. We're going to multiply it by 10 to the 8th. 10 to the 8th would have 8 zeros. Okay, this number that we will get will have 9 digits. So all we need to do is copy these digits like that, then add 0 so that we get a total of 9 digits. Okay? The same here. We copy all these digits and then add enough zeros to get a total of not 11 but 12 digits. So I have 5 here, so I'll add 7 zeros. There we go. Now let's do it the other way around. We have some big numbers here and we will write them in scientific notation. And here we see this is actually 45 million, but we're not going to write it as 45 times 10 to the 6th. Instead, in scientific notation, the first number, the multiplier, needs to always be less than 10 and at least 1. So we have to use 4.5 instead of 45. And then 10 to what power? Well, if it had been millions, it would have been 10 to the 6th, but now it's going to be one more, 10 to the 7th. We can see that if we are looking at what is the largest, it is 4 here, in what place is it? 5 would be millions place, this is 10 millions place, and this 5 here would have been 10 to the 6th, this is 10 to the 7th. Then this one here, we have to not use 39.08 or 3908, but we have to put 3.908 as the multiplier here in the front. And then this 3 here is in what place? What power of 10? It would be 10 to the 9th. So that's what we get here. 10 to the 9th. You count all these digits, 9 digits here. This is the 10th digit. 9 becomes the exponent, because if it was just 3 and followed by zeros, you would have 9 zeros. Here we have 2 numbers that are written incorrectly in scientific notation. So why is that? The first one has 54 as the multiplier, but it should be a number between 1 and 10. And the other one has the same problem. It's less than 1. We have to fix this. So how does this go? 54 becomes 5.4. Then the exponent changes, but how? This is how I think about it. Well, 54 becomes 10 times less. Okay, it's like I divide 54 by 10 to get this. So then that 10 times 10 comes here, and this 10 to the 9th is multiplied by 10 again, so it gains an exponent here and becomes 10 to the 10th. Here, instead of 0.378, we need to write it as 3.78, okay? So this here needs multiplied by 10 to get 3.78. So I took the 10 from there, and that leaves 1 10 less. And so it's only 20 copies of 10 multiplied by itself that's left here. I hope you followed my reasoning. This number here, I had to multiply it by 10 to get it to be between 1 and 10, 3 point something. So then, that 10 came from this 21 copies of 10. So then it leaves 1 copy less of 10 multiplied by itself. Okay, so now they are correctly written in scientific notation. And I hope this was helpful.